Okay, in this video I will be explaining to you certain basic concepts relating to operations on matrix. Okay, now the first one is interchange of rows and column. So let's say you have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. We know this is row 1, this is row 2, this is row 3. This is column 1, this is column 2, and this is column 3. The first operation comes in as interchange of rows. So let's say you want to replace row 1 with row 2. So you write this as row 1 interchange with row 2. There is an arrow on both the sides, so you write it something like this. There's a straight line with an arrow on both the sides. Why? Because row 2 replaces row 1, and similarly row 1 replaces row 2. So when row 2 replaces row 1 in the new matrix, row 1 will be what? It will be actually row 2. So what do? We pick up row 2, which is 2, 5 and 8, and replace it at the position where actually row 1 was. So when row 1 is interchanged with row 2, we pick up row 2, put it at the place where row 1 was. Similarly, instead of row 2, now what is supposed to come in? It actually row 1. So we pick up the row 1 from here, which is 1, 4 and 7, and put it at the position of row 2. Right? So there's an interchange of row 1 and row 2. Now row 2 became row 1 and row 1 became row 2. There's no operation on row 3, so we just write it as it is. Right? Very simple operation. Row 1, put it at the place where row 2 is. Row 2, put it at the place where row 1 is. Row 3 remains as it is. So this is called an interchange of rows. Let's see at interchange of columns. Let's say you have to replace column 1 with column 3. Okay. So in the revised matrix, now column 1 is to be replaced by column 3. So you move column 3 and put it at the place where column 1 is in the revised matrix. So you had 7, 8 and 9 as column 3. So you will put 7, 8 and 9 as column 3. Right? Similarly, column 2. Is there some kind of an operation at column 2? No. So it remains as it is. 4, 5, 6. We just put it as it is. Right? Column 3. Now column 3 is supposed to be replaced. I'm sorry, this has to be both the sides. Column 3 has to be replaced by column 1. So you put in the value of column 1 and interchange it at column 3 level. So 1, 2, 3. So this basically is the first operation on rows and columns, where you interchange one row with another row. Now the second thing can be where you have to multiply any element of a row or a column by a non-zero number. Again, let's say you have a matrix 1, 2, 3, 4. This is R1, this is R2, this is C1 and this is C2. Right? So let's say you were told R1 4 times R1. Now by writing this, what do you mean? Basically what this means is that each of the elements, let's say where is R1? R1 is this, 1, 3. What we mean by this is that R1 is to be changed such that R1 becomes 4 times R1. Or what this means is each of the elements of R1 has to be multiplied by 4. So in the new matrix, what will we have? We'll have 4 into first element of R1, which is 1. So you will do that something like this. 4 into 1 is equal to 4. Then 4 into 3 is equal to 12. Right? Insofar as row 2 is concerned, there is no change, so the elements remain as it is. So this becomes the new matrix. Let's call this as A1, if this was A. Right? Let's say you were also told that you have to find out this A2, wherein C2 is equal to, not equals to, C2 such that 3 times C2. So C2 is to be interchanged with 3 times C2. Where is C2? C2 is basically this part. So when you write A2 is equal to C1, there's any change? No. So we just write as it is. C2 we have to replace such that it becomes 3 times the earlier C2. So we write this as 3 into 3, 9, 3 into 4, 12. Right? Okay, now let's see the third operation. Addition of one row stroke column corresponding elements of another row. Okay, so let's say you have this matrix A. What this third operation refers is addition to one row or column. So let's take row 2 first. So we say row 2. Okay, row 2 is to be changed. It's not an interchange, it's to be changed. Okay, how come? Corresponding elements of another row. So let's say we add R1 to it. So we say R1 plus column when multiplied by a non-zero number. Okay. So basically what happens here is we form R2 in such a manner that we add on another row. Okay. We multiply that row by a particular number. Let's say we multiply this also by 3 and we add the existing row to it. Right? So this basically means you add on another row. This is the original one. You add on addition to one row corresponding elements of another row, which is R1 when multiplied by a non-zero number. This is something which is not required. Right? So we basically change row 2. So we write this as A is equal to. So in row 1 there is no change. I write it as it is. Now row 2, first element, 2. Now what will 2 be replaced with? 2 will be replaced with R2, which is 2. So you take the corresponding element of R2, right, which is 2. Take the corresponding element of R1, which is 1. Multiply it by 3. Whatever is the result, let's say 5 in this case, that replaces 2. Similarly, for 5, okay, this is the second number in R2. This will be replaced by what? This will be replaced by 3 times R1. What is the R1? R1 is the corresponding element. So 4 into 3 plus R2, 5. 12 plus 5. 17. Again, for 8, what is the corresponding number? 7. So we multiply 3 into 7 because 3 into R1 plus R2, which is 8. So 3 into 7 gives you 21 plus 8 gives you 29. and then you write the third row as it is because there are no changes in that. Okay, now I'll leave one problem to you. You have to find out C2, okay, such that C2 is equal to C2 plus 2 times C1, and change the elements of this row. The answers I'm writing here, but please only look at them after you've done with the question. So the new element of C2 will be these, okay? Just try and solve this at your own.